Hi there! Thanks for joining Clark Planetarium for another on-site science demonstration. Cynthia is going to be demonstrating what we're talking about, and I'm your narrator, Michelle. When we look up in the sky, we can't see where Earth's atmosphere ends and space begins, but it's somewhere around 6,000 miles above the surface of the Earth. The atmosphere is made up of 5 different layers that are stacked on top of each other, and each layer is unique. So let's break each one down a bit, shall we? The lowest layer, the one that we live in, is called the troposphere. It's the thinnest layer of them all. It's only about 7 miles thick on average, but it's the most important because this is the layer that contains the air and water vapor we need to survive. It's also the warmest, which is important for our survival. Generally, the higher you go in the troposphere, the lower the temperature gets. That's because most of the heat in the troposphere is created by the transfer of energy from the Earth's surface. This transfer of energy isn't even across the globe, though. Areas near the equator are hotter than areas near the poles. The warmer air rises higher in the troposphere, while the cooler air sinks down to replace the warm air. This movement creates an air current, or wind, called a jet stream. The jet stream is a big factor in determining our weather, like rain and snow that happens only here in the troposphere. Pretty much all of the clouds you see are in the troposphere. There are a few cloud exceptions, though. The tops of some thunderclouds can rise above the troposphere, and also nacreous clouds are often found in the layer sitting right on top of the troposphere, the stratosphere. Nacreous clouds are important because they contain nitric acid that contributes to the depletion of the ozone layer that's found in the stratosphere. The ozone layer is important because it blocks much of the sun's ultraviolet radiation. Too much exposure to ultraviolet radiation is what causes sunburns and can even lead to skin cancer. That's why it's important to cover up and wear sunscreen while you're out playing in the sunshine. And you might think that the temperature profile in the stratosphere would be like the temperature profile here in the troposphere, where it gets colder as you can go up. But actually, because of the UV radiation, it actually gets warmer the higher you go in the stratosphere. And even though weather balloons can reach the stratosphere, it's pretty much cloud and weather free, except those specific clouds we just discussed. The stratosphere is also the highest part of the atmosphere that jet planes can reach. Sitting on top of the stratosphere is the mesosphere. Here in the mesosphere, we find the coldest place in the entire atmosphere. The average temperature is around 85 degrees Celsius. That's 120 degrees below zero in Fahrenheit. That's cold. The mesosphere is also a cool place. Get it? A cool place? Because it's where most meteors burn up as they enter our atmosphere. So when you look up and see a shooting star, that's a meteor in the mesosphere. Try to say that 5 times fast. Next is the thermosphere. This layer is kind of like the stratosphere, where temperatures increase with altitude. This is my very favorite layer of the atmosphere because the thermosphere is where we find the aurora borealis, also known as the northern lights. The aurorae are cool light displays in the sky that we can see at night in the extreme northern and southern latitudes. Even though we can only see the lights at night, the aurorae are actually caused by solar flares of the sun. Solar flares release small charged particles that travel down the magnetic fields from the poles and interact with gases in our atmosphere. When these charged particles interact with oxygen, we see green and red light, and nitrogen glows blue and purple. Another cool fact, and why the thermosphere is my favorite layer, the International Space Station orbits in the thermosphere. The space shuttle also used to orbit in this layer until it was retired in 2011. The top layer of our atmosphere is the exosphere. This is the thickest of the layers, stretching from around 440 miles all the way up to around 6,000 miles. This is where the boundary between Earth and space gets blurred. Molecules found here are at extremely low density, so this layer doesn't behave like a gas, and lone elements like hydrogen and helium can easily escape into space. The exosphere is where most satellites exist as they orbit the Earth. Now that you know about the 5 different layers in our atmosphere, it's time to color and assemble your kit. The kit you got from the planetarium should contain a sticker sheet, a planet Earth, 5 hemispheres that represent the different layers of the atmosphere, and a blue strip of paper that you can use to keep it all together. The first thing you can do is color your stickers. Those represent some of the different things that we talked about finding in layers of the atmosphere. Next, get your different layers of the atmosphere and staple them together at the bottom so that they can fold down, and you'll be able to put your stickers on the layer of the atmosphere where they belong. If you have a hard time knowing which stickers go in which layer, you can rewatch this video or read through your packet. Finally, you can attach Earth and then staple that blue strip of paper to the bottom to give it a nice finishing touch. Happy atmosphering!